Hi, everybody. This is a continuation of section 6.5 on exponents and scientific notation. This is where we left off in class last time, and then I'll stop just before we get to scientific notation because I have that in a different video. So the next exponent rule is the quotient rule for exponents, which says that if x is a non-zero real number, and both m and n are natural numbers, then x to the m divided by x to the n is equal to x to the power m minus n. So if you put this side by side with the product rule, it makes logical sense. The product rule said that when you multiply powers, x to the m times x to the n, you add the exponents. So this is saying if you divide the powers, then you subtract the exponents. So that makes sense. So here's how it works, and then I'll show you sort of why it works this way. So if you take 3 to the 7th divided by 3 to the 5th, this rule says that that's equal to 3 to the power 7 minus 5, which of course is 3 to the 2nd power, which is 9. And here's why that works. If you write out 3 to the 7th as 7 copies of 3, and then 3 to the 5th as 5 copies of 3, you can cancel 5 copies of 3 from the numerator and the denominator, leaving you just the 2 copies in the numerator, and that's how you get 3 to the 2nd. All right, and then the quotient rule leads us to a rule for 0 exponents. So far, we've only talked about exponents being natural numbers. So the rule says that any number except 0 to the power 0 is equal to 1. So if you use the quotient rule that we just talked about, 17 to the 9th divided by 17 to the 9th would be 17 to the power 9 minus 9, which is 17 to the 0. And it makes sense that it should be that because we're dividing a number by itself. So any number divided by itself is 1, unless the number is 0. 0 divided by 0 is undefined, and that's why 0 is excluded from this rule. All right, next, we have a rule for negative exponents. So first, it's saying that a to the 0 is equal to 1. And if n is a natural number, 1, 2, 3, 4, 5, et cetera, then a to the power negative n is equal to 1 over a to the n. In other words, a to the negative n is the reciprocal of a to the n. So here's an illustration of how that works, followed by why it works. 7 to the 5th divided by 7 to the 8th, according to this rule, would be 7 to the power 5 minus 8. That's actually according to the quotient rule. 5 minus 8 is negative 3, and now according to this rule, 7 to the negative 3 should be equal to 1 over 7 to the 3, which is 1 over 343. Here's why that rule makes sense. 7 to the 5th divided by 7 to the 8th, you have 5 copies of 7 in the numerator. You have 8 copies of 7 in the denominator. You cancel out 5 copies of 7. You're left with 3 copies of 7 in the denominator. So that's why you get 1 over 7 to the 3rd. All right, here is a quiz yourself, which I will also put separately in a PDF. All right, so now we can extend the exponent rules to all integer exponents because we started off doing them for natural numbers only. And now we've just talked about what it means for an exponent to be 0 or for it to be a negative number. Just as a note, all these exponent rules actually work for any real number exponents, but that's not something we get into in this class. Actually, real number exponents, you don't really get a good definition of those until calculus, but they work the same way. All these rules work even if the exponents are real numbers. All right, so for example, multiplying 5 to the negative 4 times 5 to the 7th, that is the product rule. This is where you add the exponents. So that would be 5 to the power negative 4 plus 7, which is 5 to the third, which evaluates to 125. The second power of 2 to the negative 3, this is an example of the power rule. So we're going to multiply the exponents. That'll be 2 to the power negative 3 times 2, which is 2 to the power negative 6. And then according to the negative exponent rule, 2 to the negative 6 is 1 over 2 to the 6th. That evaluates to 1 over 64. And finally, negative 3 to the power negative 2 divided by negative 3 to the power negative 7. This would be an example of the quotient rule. So we're going to subtract these exponents. Be very, very careful. Subtracting negative 7 from negative 2. We're going to get negative 3 to the power negative 2 minus negative 7. Remember, when you subtract integers, we talked about that being meaning add the opposite. So negative 2 minus negative 7 is the same thing as negative 2 plus 7. So this is the fifth power of negative 3, which comes out to negative 243. All right, so I'll end this video just by showing you the next quiz yourself, which again will be in a separate PDF. So please go to the next video for scientific notation, and have a great day.